Hello viewers, we are given this circle and then we are asked to find all the angles within these parts I am indicating. How do we get those four angles? Firstly, recall that sum of angles on a straight line is equal to what? 180 degrees. So this angle plus this angle is 180 degrees because both of them falls on a straight line. So in order to get the angle here, we'll subtract 64 degrees from 180 degrees. When you subtract 64 from 180 degrees, the angle here is 116 degrees. That is the angle there. Next, we have three more angles to get. How do we get them? Now let's find the whole angle here in order to get the angle here, because this is what? A major arc. The angle subtended by the arc at the center is twice the angle it subtends on the circumference. So let's use that major arc, the angle subtended at the center, to get the angle here. Now what is the angle subtended at the center here? It is 64 plus what? 180 degrees. 64 plus 180 degrees will give 244 degrees. So that is the angle subtended at the center by this major arc. Now the angle subtended at the center by this major arc is known to be twice the angle it subtends on the circumference. So if the angle here is 244 degrees, the angle here will be 122 degrees. 122 degrees, sharing this into two. Angle at center is twice that on the circumference. So we have gotten two angles now. We are left with two angles. How do we get them? I am going to draw a line here to bisect the angle at C. I am going to draw a line there to bisect the angle at C. This is a radius, this is a radius, this is a radius. All radius have equal length. Now, what is the significance of these two signs? What is the significance of these two signs and what is the information they convey? They tell us that the length of this chord is the same as the length of this chord. Now, can you remember that equal chords subtend equal angles at the center? These two chords, they have equal length. There's a theorem that states that the angle they subtend at the center is equal. So if the whole angle they subtend at the center is 116, dividing that into two, we're going to have 58 degrees here, 58 degrees here. The reason is because equal chords subtend equal angles at the center. So now, knowing that the angle here is 58 degrees, how do we get this angle and this angle? Can you see that this triangle is isosceles? Because of these two signs, two sides are equal in length. So this triangle is what? Isosceles. What do we know about isosceles triangle? Base angles are equal. Okay? So when you subtract 58 degrees from 180 degrees, you know the sum of the three angles is 180 degrees. Subtracting 58 from 180 degrees, we are going to get an angle which we are going to divide into two to get this and this. Subtracting 58 degrees from 180 degrees, since sum of angles in the triangle is 180 degrees, we are going to get 122 degrees. So 122 degrees will be shared into two equally. Sharing 122 into 2 will give the angle here as 61 degrees. 61 degrees. So we have eventually gotten three angles. The last angle to be obtained is this. How do we obtain that angle? Now I am going to use this arc I'm going to use arc AC. That arc subtends this angle at the center. The angle it subtends at the center is twice the angle it subtends on the circumference. Can we see that? So what is the angle that this arc subtends at the center? The angle is 58 plus 64. 58 plus 64 would give 122 degree. So angle at the center is twice the angle it subtends on the circumference. So if we share 122 into 2, we're going to get the angle here as 61 degree again. So the four angles have been obtained. The angle at O was 116 degree. The angle here is 61 degree. The angle here is 122 degree. The angle here is 61 degree. Thank you for viewing. For more exciting videos like this, kindly subscribe to my channel.